The current waveform depicted in figure 2.28 is characterized by a period of 4 seconds. What is the average value of the current over a single period? Compute the average current over the interval 1 is lesser than time lesser than 3 seconds. If charge quantity of 0 is equal to 1, C, sketch charge quantity of time 0 lesser than time lesser than 4 seconds. So the first thing we will be performing is to calculate the average value of average value over the single period of single period. So this equation is a time varying current. So this would be our mathematical equation for the current waveform. So the period of the waveform is t is equal to 4 seconds. So I, with respect to time, so yeah, this is the mathematical waveform. So the first thing we will be performing is to calculate the average value of the current over the single period. So average current is equal to 1 over time, derivative of time, or subcurrent quantity of time. So this is our formula. So we basically just need to distribute its value. So since we're talking about 4 seconds, so that is why the value of time is 4. So we just distributed its value, and so right over here, so at 3 amps, as you may see, at 3 amps, so its time is 1, so we don't need to put that, but yeah, just put time there and our current quantity of time here. And at negative 1 amps, it is raised to 2 and sub 1. So and so on, this one, like this one, 1 amps and raised to 2, and I mean no, 1 amps raised to 3 is our time varying in time to with time which is its unit is seconds, 3, and current quantity of time which is 2. So for 0 amps, 4 is to 4 and 3 right over here. So by calculating this one, it would result to this one, so 1/4. So basically we just derived our values and resulted into this one. So yeah, 3, we copied 3, and the derivative of time is time itself, and it's raised to 3 and sub 0 minus derivative of time which is time and raised to 2 and sub 1. So the rest is just derivative of time, and derivative of time is time and raised to 3 and 2. The derivative of this one is equivalent to 0. By computing this one, it would result to 1/4 quantity of 3 minus 1 plus 1. So our average current over a single period is 3/4, which if we make it into decimal value, it would be equal to 0.75 amps. But we're trying to find the answer by milliamps. So we just basically moved it into 3 decimal point, and it is equal to 750 milliamps. So the next step we will be performing is to calculate the average current over the interval 1 is lesser than time lesser than 3 seconds. So this is our formula. So basically we will be starting to, just like the previous step, we just need to distribute its values So 1 over 3 minus 1, quantity of negative 1 derivative of time plus derivative of power of 3 sub 1 1 derivative of time. So by calculating this one, it will result to 1 over 3 minus 1 is equal to 1 half, and we've taken its derivative and it is equal to negative quantity of time raised to 2 sub 1 plus quantity of time raised to 3 sub 2. So by computing this one, it would result to 1 half quantity of minus 1 plus 1, which is equivalent to 0. So our average current over the interval time, 1 is lesser than time, lesser than 3 seconds, is 0 amps. So this would be our final answer. And so the next step we will be performing is to calculate the charge over the interval 0 is lesser than time, lesser than 1 seconds. So this would be our formula. So since it is 0, lesser than time, lesser than 1 seconds, so this is what it is talking about. So distributing its value, our current is 3. So we distributed 3 derivative of time plus 1, because our charge is equal to 1. So basically we just distributed its value, and so we've calculated its derivative, and it resulted to 3 quantity of time raised to the power of 1 sub 0 plus 1. So by calculating this one, this would be our final answer. So the next step we will be doing is to find the value of charge at t is equal to 1 seconds. So charge quantity of time is equal to 3 quantity of time plus 1. So the value of our time is 1. The value of time is 1. So our final answer is 4C. So jumping into the next step we will be performing is to calculate the charge over the interval of 1 is lesser than time lesser than 2 seconds. So basically this is it. So charge quantity of time. So this is our formula for this problem. So distributing its values, derivative raised to 2 sub 1. So our current, the value of our current is negative 1 amps, derivative of time plus 4. So we're asa ta nangita sa 4. So dara atong 4 atong na solve gaina, and so taking the derivative of this one, it would result to negative quantity of time raised to power of 2 sub 1 plus 4. So this is our final equation. So what's the next step we will be doing? So we will find or calculate the charge over the interval. Find the find the value of the charge at time which is equal to 2 seconds. So charge at 2 is equal to 4 minus 2, and so 4 minus 2 is basically 2C. And so the next step is to calculate the charge over the interval 2 is lesser than time lesser than 3 seconds. So this would be our formula. So the time is 3, and the current, not current with respect to time is 2. So distributing its formula, it would result to this one. So our current is 1 amps. 1 amps plus 2, which is 2 is taken from our charge right over here, and by taking its derivative, it would result to quantity of time raised to the power of 3 sub 2 plus 2. So our equation would look like this one: quantity of t plus 2 c. So we've taken the value of the charge at t is equal to 3 seconds. So I mean charge quantity of 3 is equal to 2, and the our 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 3 2 plus 3 is equal to 5c. So this is our final answer. So next step, we will be calculating the charge over the interval 3 3 is lesser than this one. 3 is lesser than time lesser than 4 seconds. So this will be our formula. This will be our formula, and so we distributed its values into this one, and by taking its derivative, it basically resulted. I just jumped and it just basically resulted into 5c. So the next thing is to find the value of the charge at time, which is equal to 4 seconds. So quantity, which is time 4, is equal to 5c. So the last and final step is to sketch the charge quantity of time over the interval, which is 0 is lesser than time lesser than 4 seconds. So charge quantity of time c with respect to time quantity of seconds. So this is basically our sketch diagram. A local restaurant has a neon sign constructed from 12 separate bulbs. When a bulb fails, it appears as an infinite resistance and cannot conduct current. In wiring the sign, the manufacturer offered two options. From what you've learned about KCL, which one should the restaurant owner select? Explain. So basically, current here, if any bulb would be busted out, like for example any letter P, the bulb here would be busted out, the cannot can, can current cannot be transmitted to the rest of its the rest of its the rest of this circuit. So basically the circuit would be terminated. Unlike it here, if any of the bulb here, like for an example, if the bulb here in T, current could still flow right here, here, here. So if I would be the restaurant owner, I would basically select this one. So supernode analysis. Referring to the circuit figure 4.48, obtain a numerical value for the power supplied by the 1 volt source. So KCL at node 1. So negative 4 plus 6 plus our V1 minus V2 minus 4 all over 21. So this is our V1, then V2 minus this voltage source all over 14 plus 7, which is 21, is equal to 0. So 2 plus V1 minus V2 minus 4 all over 21 is equal to 0. We computed this one and come up to 2, and then multiplied this constant number by 21, and this one right here is, because this is 21, so it will be cancelled. 42 plus V1 minus V2 minus 4 is equal to 0. So I computed common terms, which is the constant 42 and negative 4. So copy V1 minus V2 plus 38. So the next thing, we will transpose this constant to the other side, which became negative 38. So it resulted to V1 is equal to V2 minus 38. So KCL at node 2. So V1 minus V2 plus 4. This is our node 2. V1 minus V2 all over this voltage source. All over, V1 minus V2 plus this voltage source all over 14 plus 7, which is 21. So next, plus V2 minus 1, this is our V2 minus this one, our voltage source, V2 minus 1 all over this resistor, which is 2. So V2 minus V3 plus 3. So our V2 minus 3 plus this voltage source all over 7 is equal to 0. So we computed this one. So 2V2 minus V1 plus 4. So this is 2 cross multiplied 2 2V2 minus V2 minus V1 plus 4 plus 21 V2 minus 1 plus 6 quantity of V2 minus V3 plus 3 all over 42, which is their common denominator is equivalent to 0. So by we distributed its values. So 2V2 and then 2V1 plus 8 plus 21V2 minus negative 21 plus 6V2 minus 6V3 plus 18 is equal to 0. So we computed or calculated the same terms. And then our constant would be equal to 5 minus 2V1 plus 29V2 minus 6V3. So 5, because it is negative 21 plus 18 is equivalent to 5. And 2V1, so since there is no other V1, so we copied it. 29V2, how many V2 we have? 2V2, 21V2, and 6V2. So 29V2 minus 6V3, which is the only V3, and is equivalent to 0. So we transpose the constant to the other side. It became negative. So this is our equation for node 2. KCL at node 3. So negative 6 plus V3 minus V2 minus 3 all over 7. So this is our V3 minus this node minus this voltage source all over this resistor. Then the next one plus V3 all over 3 V3 and all over this resistor 3 is equal to 0. So I multiplied negative 6 by 21 because since 21 is their common denominator, which I place also here, and then the 21 would be cancelled. Negative 126 plus 3V3 minus 3V2. So simply distribute these values and you come up to this one, and then equal to 0. And then I place them in chronological order, like V2 and then the next V3 and then next the constant. So our constant, so where did I get negative 35? Negative 126 minus 9 is negative 135, and then equal to 0. And then negative 3V2 plus 10V3, then I place the constant I transpose the constant to the other side, 135. So this will be my equation for node 3. So as you may see in the equation of the node 2, we will substitute the values of V1 and V3. So negative 21V1 plus 29V2 minus 6V3 is equal to negative 5. So our the value of our V1 is equal to V2 minus 38. So V2 minus 38 plus 29V2 minus 6. Our V3 is 3V2 plus 135 all over 10. So place it here, then equal to the constant. And the next thing, this equation, we will multiply it by 10 to cancel this denominator. So the result would be negative 20V2 plus 760 plus 200V2 minus 18V2. Oh, I forgot the sign. this will be negative 810 equals to negative 50. So we calculated this term, the common terms, the V2, V2, and V2. So negative 20 plus 290 V2 minus 18 V2 is equal to 252 V2 minus, you compute these constant numbers then equals to copy this one, negative 50. So we have a constant here, we will transpose it to the other side. So 252 V2 all over negative 50 plus 50. So negative 50 plus 50, we know it's already 0. So 252, we multiplied both sides by 252. So 0 divided by 252, we know that the answer is 0. So the value of V2 is equal to 0 volts. So the next one, so now we will substitute um, the values of our V1. Our V1 is V2 minus 38. So this is it. V1 is equal to V2 minus 38. Our V2, we already computed our V2, which is equal to 0 volts. So 0 minus 38. 0 minus 38 is equal to negative 38 volts. And so we will also compute the value for V3. We know our V3 is 3V2 plus 135 all over 10. So we know our V2 is equal to 0 plus 135 all over 10. So 3 multiplied by 0, we know that it's 0. So it would be 135 over 10. So 135 divided by 10 is 13.5 volts. So to compute the value of our current, we will use the formula negative V2 plus 1 all over 2. So we know our V2 is 0. So 0 plus 1 is 1. So 1 half, or 1 half, is equivalent to 0.5. So our current is 0.5 amps. So to compute the value of power, we know that the formula for power is volts multiplied by this current. So our volt given in the problem is 1 volt. So our current is 0.5 amps. So 1 multiplied by 0.5 is equivalent to 0.5, and the unit for power is watts. So that will be all, and thank you. Supermesh analysis. So this is our original equation. So we have three unknowns, I1, I2, and I3. So we basically need three equations. By definition, a supermesh has no current source of its own. So we will be removing this portion here, here, and here. So the first thing we need to do is reconstruct or redraw the equation. So it would look like this one. We just exclude the current sources. So we will conduct a KVL at supermesh. So 8, since current is flowing from the positive side of the voltage source, and then we'll travel into here, and our current is coming in, is moving to the negative side of the battery. So we assign this as negative 2 plus 2i3, 2 here, 2i3 minus 3. So the current is coming to the negative side of the battery, 3, and then our 3 ohms is shared by our I2, and this one here, since it has no label, we will consider this as our I4. So 3i2 minus I4 plus 5, so our 5 here is shared by our I1 and I4. So this one, I1 minus I4, this is equals to equals to 0. So we will distribute our values, so it will look like this one, and also the constants, we calculated it, and 8 minus 2 minus 3 is equal to 3. So 2i3, we copied i3, 3 we distributed it here, and 5 we also distributed it here, and is equal to 0. And so I ordered it, I placed it in chronological order. So it looks like the ones like I1, I2, I3, and I4. 5i1, 3i2, 2i3, 3i4, 5i4. Plus 3, our constant here. So 5i1, 3i2, and 2i3, 8i4. So we calculate it here, and it's equal to negative 8i4. And we transpose the constant to the other side, and copy again, 5i1, 3i2, 2i3, minus 8. So our i4 is 3, as you may see here. Our current is equal to 3 amps. So 3 is equals to negative 3, our constant. 5i1, 3i2, plus 2i3. So our 8i4 became negative 24. So we will be transposing it to the other side. So this is it, negative 3 plus 24, and this is our first equation. So we will we'll perform KCL at point node A. So this is our node A. So I2, here the current I2 is coming in, so it is positive coming in, and negative because our I1 is coming out. Here I1 coming out from our node, and also our 1 amps negative is equal to 0. So this is we just transpose the constant to the other side, and it became a positive. So KCL at point B. So our I1 is coming in to the node, positive and negative because it is coming out from the node, and also positive 2 for our voltage source is equal to 0. So we transpose the constant to the other side, and it became negative 2. So we copied our equation 1, our equation 2, equation 3. So here it is, and we just take their values. So this is it. So we will be performing Kramer's rule. So to get Kramer's rule, we will take the quantity of our delta. So this is their values, 5 plus 3 plus 2. So what we will be doing is we will use our calculator and get their determinant. So mode 6, which is matrix A, and 3 by 3 since it is 3 by 3. So 5 plus 3 plus 2, 5, 3, and 2, and negative 1, negative 1, 1, and 0, and 1, 0, negative 1. So press AC and it will automatically be saved, and shift matrix determinant, shift again matrix, and 3 matrix A because our data recently it would be saved and stored here, matrix A. So it is equals to negative 10, as you may see, negative 10. So to get our determinant delta 1, so we will perform again doing the calculator. Basically this one here, we just change these values here into our constants. So mode matrix A, and 3 by 3. So 21, 3, 2, 1, 1, 0, negative 2, 0, negative 1. So press AC and it will automatically be stored in our matrix A. Shift matrix determinant, shift again matrix A. So negative 14. So negative 14. So to get the value of I1, so we will dividing delta 1 divided by the delta. So the value of delta 1 negative 14 and value of delta is negative 10. So it would be equals to 1.4. So we have our value, our formula here at KCL point node A. So this is it, and we'll just be deriving this formula, and it will be I2 plus I2 is equal to I1 plus 1. So our value of I1 is 1.4 plus 1 and is equivalent to 2.4 A. So to get the value of our I3 again, we have our formula here, but you can also do it like this one, get the determinant and make use of your calculator. So basically the last term, the last column terms or values, you just replace it with our constant. So it would look like this one. So we'll use our calculator. So mode again, matrix A 3 by 3. So 5 3 21 negative 1 1 1 again 1 0 negative 2. So press AC and it will be stored in our matrix A. Shift matrix determinant, shift matrix again, and matrix A, and it is equivalent to negative 34. So I3 is equal to determinant 3 over its determinant. So we know our value of our determinant 3 is negative 34 and our delta is negative 10. So we divided it and it is equivalent to 3.4. But we have our formula here. So you can also use that and I1, and we will derive this one, and it would be I3 is equal to I1 plus 2. So our I1 is 1.4, and 1.4 plus 2 is equal to 3.4. So basically they are just the same. So that would be for our super mesh.